Hello everyone, myself Dr. Ashalata KS. Today we shall discuss limit, continuity and differentiability of functions. Definition of limit of a function. A function f of x is said to tend to a limit L as x tends to a if for a given positive real number epsilon, however small, there exists a positive real number delta such that modulus of f of x minus L less than epsilon whenever 0 less than modulus of x minus a, which is less than delta. Symbolically, limit of the function can be denoted by limit x tends to a f of x equal to L. Left hand limit. A function f of x is said to tend to a limit L1 as x tends to a from the left. If for a given epsilon greater than 0, however small, there exists a real number delta greater than 0 such that modulus of f of x minus L1 less than epsilon whenever a minus delta less than x, which is less than a. Symbolically, limit x tends to a minus f of x equal to L1. Right hand limit. A function f of x is said to tend to a limit L2 as x tends to a from the right if for a given epsilon greater than 0, however small, there exists a real number delta greater than 0 such that modulus of f of x minus L2 less than epsilon whenever a less than x, which is less than a plus delta. Symbolically, this can be denoted by limit x tends to a plus f of x equal to L2. If left hand limit equal to right hand limit, then you are going to say the limit of the function exists and it is limit x tends to a f of x equal to L. Now we shall know how to evaluate left hand limit and right hand limit. In order to find out the left hand limit for the function f of x, just replace x by a minus h in the function f of x. That is, left hand limit equal to limit x tends to a minus f of x equal to limit h tends to 0 f of a minus h. Similarly, right hand limit equal to limit x tends to a plus f of x equal to, just replace x by a plus h. Limit h tends to 0 f of a plus h. Now we shall solve a problem in order to find out the limit of a function. That is, if f of x equal to x plus 1 for 0 less than or equal to x, which is less than or equal to 1. And the function is 3x minus 1 for x greater than or equal to 1. Then find limit x tends to 0 f of x if it exists. So first of all, find out the left hand limit. That is, limit x tends to 1 minus, that means x is less than 1. So for this, we'll consider the function f of x as x plus 1. So here, replace x by 1 minus h. So you will have x is replaced by 1 minus h, that is 1 minus h plus 1. Okay, now apply the limit as h tends to 0. So you will left with 2. Now find the right hand limit. Limit x tends to 1 plus for f of x, which is equal to, since x tends to 1 plus, that means x is greater than 1. Therefore, the function is 3x minus 1. So here, in this case, replace x by 1 plus h. That is 3 into 1 plus h minus 1. So therefore, after applying the limit, it will be 2. So left hand limit is equal to 2 as well as right hand limit is equal to 2. Therefore, the limit of this function exists and it is 2. Continuity of a function at a point. A function f of x is said to be continuous at x equal to a if it satisfies the following condition. The first condition is f of x is defined at x equal to a. That means f of a exists. Second one, left hand limit equal to right hand limit and it exists. That is, limit x tends to a, f of x exists. Third condition is limit as x tends to a, f of x is equal to f of a. If any one of these conditions is not satisfied, then the function f of x is said to be discontinuous at x equal to a. We shall discuss a problem here. Discuss the continuity of the function f of x equal to 3x minus 2 when x less than 1 and it is 4x squared minus 3x when x greater than or equal to 1 at x equal to 1. Given when x equal to 1, the function is 4x squared minus 3x. Here replace x by 1, you will get f of 1 equal to 1. The second condition, therefore f of a exists. The second condition, find out left hand limit, that is limit x tends to 1 minus, that means x is less than 1. We'll consider this function 3x minus 2. Here in this case replace x by 1 minus h. You will have limit h tends to 0, 3 into 1 minus h minus 2. Now apply the limit. You will get the value as 1. Right hand limit, limit x tends to 1 plus f of x equal to. In this case f of since x tends to 1 plus, that means x is greater than 1, we'll consider the function f of x as 4x squared minus 3x. So here replace x by 1 plus h. You will have 4 into 1 plus h whole square minus 3 into 1 plus h. After simplification and applying the limit, you will get its value as 1. Observe here, the left hand limit value is 1 and the right hand limit value is 1. Therefore, both exist and they are equal. Therefore, the second condition is satisfied. Now, the third condition, limit x tends to 1, f of x value is. Okay, so we will substitute the value of x as 1 here. So, after applying the limit, you will get its value as 1, and we have also find out that f of 1 value is 1. Therefore, limit x tends to a or x tends to 1, f of x equal to f of 1. So, therefore, this function satisfies all the three conditions of continuity. Therefore, the function is continuous at the given point x equal to 1. Now, differentiability of a function. A function f of x is said to be differentiable at x equal to c if and only if both left hand derivative and right hand derivative exist and are equal. Then we are going to say the function is differentiable, or otherwise it is not differentiable. First, let's know what is left hand derivative. Let f of x be a function which is defined in the interval closed interval a comma b and c belongs to a comma b. Then limit x tends to c minus equal to f of x minus f of c divided by x minus c, or its limit h tends to 0, f of c minus h minus f of c divided by minus h exists. Then this limit is called the left hand derivative of the function f of x at x equal to c and is denoted by L of f dash of c. Right hand derivative, let f of x be a function which is defined in the interval a comma b and c belongs to a comma b. Then limit h tends to 0, f of c plus h minus f of c divided by h exists. Then this limit is called right hand derivative of the function f of x at the point c and it is denoted by r f dash of c. We'll discuss a problem here. If f of x equal to x square sine 1 by x when x not equal to 0 and the function f of x equal to 0 if x equal to 0. Examine whether the function f of x is differentiable at x equal to 0. Okay. So for x equal to 0, what is the function value? For x equal to 0, f of x is 0. That is f of 0 equal to 0. And for all other values of x, that is for x not equal to 0, the function value f of x is nothing but x square into sine 1 by x. Now we'll find out the left hand derivative. As we know, it is given by limit h tends to 0, f of 0 minus h minus f of 0 divided by minus h. That means in this function, we are going to replace x by 0 minus h. So it's 0 minus h whole square into sine of 1 by 0 minus h minus, we already know f of 0 value, it is 0. So therefore it is 0 whole divided by minus h. Now simplify this, 1h will get cancelled, minus h whole square is h square, 1h will get cancelled, so you are left with limit h tends to 0, h into sine 1 by h. If you apply the limit for this, this will be 0, but sine value will take the finite value between minus 1 and 1. So therefore 0 into finite value equal to 0. So we got the left hand derivative as 0. Now find the right hand derivative. Again for this also the function is x square into sine 1 by x. Here replace limit h tends to 0, f of 0 plus h minus f of 0 divided by h. Now replace the value of x by 0 plus h. You will get h square into sine 1 by h. We know f of 0 value, it is 0 whole divided by h. 1h will get cancelled. If you apply the limit for this, 0 into a finite value between minus 1 and 1, which is nothing but 0. So therefore left hand derivative and right hand derivative are equal. Hence the given function is differentiable.